All right, we're going to do one last example. In this example, we have ty double prime plus 6y prime plus 4 over ty is 1 over t squared log of t. First thing to notice, this is almost Cauchy-Euler form, but not quite. I need a t squared times the second derivative, and I need a t times y prime, and no t's there. So I multiply everything through by t. I get t squared y double prime plus 6t y prime plus 4y. T over t squared becomes 1 over t log of t. All right. At this point, you should have a very good idea of how you're going to proceed through the whole thing. You know it's going to be a mess. You know you need to be careful and just do one step at a time and don't try to skip, and be careful. You're going to make mistakes. That's fine. What's important is recognizing and catching them. All right. It is linear, so I need to find the homogeneous solution. It's Cauchy-Euler, so I know how to do that. There is no way on this green earth that I'm going to make a guess for what the solution is for that, so I'm going to use variation of parameters. So let's do the homogeneous solution first, and we'll use that to make our guess for the particular solution. And so I'm going to guess my homogeneous solution looks like Ct to the r. So my homogeneous equation is t squared times y double prime plus 6t times y prime plus 4y is all 0. And that makes it homogeneous. So if my guess is c times t to the r, I'm going to need two derivatives. So I'm going to bring down the r, make that times c times t to the r minus 1. Oops, that's the derivative. Second derivative, I'm going to bring down the r minus 1. So I have r times r minus 1 times c times t to the r minus 2. Plug this into my equation. So I t squared times the second derivative plus 6t times the first derivative plus 4 times the function is 0. All right, let me collect all the t terms. T squared times t to the r minus 2 is t to the r. Got a 6r. C, t times t to the r minus 1 is t to the r. Let me leave that alone. Now note, c times t to the r is in every term, so I can factor that out, leaving r times r minus 1 plus 6r plus 4. This is my homogeneous solution. We're assuming that's not 0, so that means that everything else has to be 0. So now I've got to solve this for, I'm just going to expand everything. So r times r minus 1 becomes r squared minus r. I've expanded everything as far as I can go, so now I'm going to start bringing things together. 6r minus r becomes 5r. And lo and behold, I can factor that to r plus 4 times r plus 1. So r is minus 4 or minus 1, so my homogeneous solution is c1 t to the minus 4 plus c2 times t to the minus 1. Okay, so my differential equation, written in Cauchy form, is t squared times y double prime plus 6t y prime plus 4y is 1 over t log of t. My homogeneous solution is c1 t to the minus 4 plus c2 t to the minus 1. So I'm going to guess for my particular solution u1 of t times t to the minus 4, which comes from that term, plus u2, which is a function of t, times t to the minus 1, which comes from that term. All right. So I'm going to plug this into my differential equation. So I'm going to need to take a first derivative and then a second derivative. So the first derivative, I've got to use product rule. It's u1 prime times t to the minus 4 derivative of t to the minus 4 becomes minus 4 times t to the minus 5. Now for the second term, u2 prime. And now derivative of t to the minus 1 becomes minus 1 times t to the minus 2. I'm going to just let that be 0. And I can do that because I have two equations, two unknowns, and I've got one equation I need to define in order to deal with that. So just let that be true. So that means now my y prime is minus 4u1 times t to the minus 5 minus u times t to the minus 2. Okay, I have a tendency to drop derivative, so I think I'm okay. So now I need a second derivative. So derivative, again, I got to use product rule. So u1 prime t to the minus 5. When I bring down the minus 5 times minus 4, that becomes plus 20, and then t to the minus 6. This becomes minus u2 prime t to the minus 2. When I bring down the minus 2, minus a minus, 2u2 t to the minus 3. Plugging this into my equation, I have t squared times y double prime. Well, that's this mess. So this becomes minus 4 u1 prime t to the minus 5 plus 20 u1 t to the minus 6 for that line. And this line becomes minus u2 prime t to the minus 2 plus 2 u2 t to the minus 3. All right, then this term is plus 6t y prime. There's my y prime. It's minus 4 u1 t to the minus 5 minus u2 t to the minus 2. Finally, plus 4y. And my y, is from this line. It's my particular solution. Is u1 t to the minus 4 plus u2 times t to the minus 1, all equals the right-hand side, which is 1 over t log of t. Okay, just as before, I'm just going to expand everything out until I can't anymore, and then try to bring things together. Multiplying through this t squared, I get minus 4 u1 prime, t squared times t to the minus 4 is t to the minus 3, plus 20 u1, t squared times t to the minus 4 is t to the minus 4, then u2 prime minus a u2 prime, t squared times t to the minus 2 is 1, plus 2u2, t squared times t to the minus 3 is t to the minus 1. 6 times minus 4 is going to be minus 24 u1, t times t to the minus 4 is t to the minus 4. Sorry, t times t to the minus 5 is t to the minus 4. This becomes minus, let me bring it over here, minus 6 u2, t times t to the minus 2 is t to the minus 1. For this line, I've got plus 4 u1 t to the minus 4, plus 4 u2 t to the minus 1, is 1 over t log of t. Notice 20 minus 24 plus 4, all those terms are the same as 0. All these are the same. 2 minus 6 plus 4 is 0. Again, if that doesn't happen, you should only have derivatives left. You did something wrong. So minus 4 u1 prime t to the minus 3 is left. u2 prime is left, and then the right-hand side was 1 over t log of t. And that becomes my second equation. So let's write all this out again. I assumed my particular solution looked like u1 of t times t to the minus 4 plus u2 of t, t to the minus 1. I have two equations, u1 prime t to the minus 4 plus u2 prime t to the minus 1 is 0. And the second equation is minus 4 u1 prime t to the minus 3 minus u2 prime is 1 over t log of t. I'm going to use the first equation to solve for u2 prime, and then I'm going to plug it into the second equation to get u1 prime and then get u2 prime, and then once I do that, I'm going to stop and then make a decision on how to proceed. So u2 prime t to the minus 1, subtract that from both sides, so it's minus u1 prime t to the minus 4, multiply both sides by 2, so u2 prime becomes minus u1 prime, t times t to the minus 4 is t to the minus 3. Plug that into this equation, so leave the minus 4 u1 prime t minus cube terms alone, minus a minus u2 prime, so minus a minus, so u1 prime t to the minus 3, and that side leave alone. Minus 4 of these plus 1 of these is minus 3 u1 prime t to the minus 3, so 1 over t log of t. Divide both sides by minus 3 and multiply by t cubed. So u1 prime is minus 1/3 t cubed times 1 over t is t squared. So there's my u1 prime. I can integrate that, and I'm going to do integration by parts, so I'm okay with that. u2 prime is going to be minus u1 prime, so minus a minus 1/3 t squared log of t times t to the minus 3. So u2 prime becomes 1/3 times 1 over 2 log of t. I don't like that. Yeah, that's not going to be fun. Let me do this one first, because that looks like it's going to be more straightforward. So I have u1 prime is minus 1/3 t squared log of t. Take the antiderivative of both sides. Antiderivative of u prime is just going to be u1. So this becomes minus 1/3 t squared log of t dt. I want to take a derivative of that. So that means my u is going to be log of t, and whatever's. So now once I make that decision, my fate is sealed. Everything is just going to do what it's going to do. dv is whatever's left. So that's my minus 1/3 t squared dt. So du, derivative of log, is 1 over t dt. V, so antiderivative of t to the minus 2. Oops, that's a t squared. So that's going to be t cubed. So that's going to be 1/3 t cubed. Yes, okay. So u1 becomes u times v, which is minus 1/9 t cubed log of t minus v du minus a minus, it becomes plus 1/9 t cubed times 1 over t. All right, so let me rewrite all of that. I am now where I have my particular solution is u1 times t to the minus 4 plus u2 times t to the minus 1. u1, let me do u2 prime first. u2 prime I said was 1/3 times 1 over t log of t, and we just found that u1 was minus 1/9 t cubed log of t plus the integral of 1 over 9 t cubed times 1 over t dt. So let me clean up the integral. This becomes the integral of 1/9 t cubed divided by t is t squared. Okay, I can do that integral. So this becomes minus 1/9 t cubed log of t, and then this becomes 1/9 times 1/3 t cubed plus, we call that k1. So that's my u1. And I put this off as long as I can. So u2 prime is equal to 1/3 1 over t log of t. Take the antiderivative of both sides. Oh, look at that. the derivative of log of t is that. So I'm going to do a u substitution. Right, because if I let u equal log of t, du is 1 over t, and that's going to pop right out. So this becomes the integral of 1/3 of u du. So this becomes 1/3 times 1/2 u squared plus k2. So 1/3 times 1/2 is u. 1/6 u is log of t. So this is log of t squared plus k2, like that. So my particular solution is u1 times t to the minus 4. Where's my u1 is this awful looking thing. Minus 1/9 t cubed log of t. 1/9 times 1/3 is 1/27 t cubed plus k1 times t to the minus 4. And then u2 times t to the minus 1, but u2 is 1/6 times the quantity log of t squared plus k2. Note, there is my homogeneous solution, so that's a quick check. None of these terms are going to be in common when I multiply. Oh, we take it back. That's going to be 1 over t. That's going to be superfluous, but I'm just going to leave it. So there is my particular solution. And I'm going to go curl up and lie underneath the desk for a while and hope that this never happens again.